Welcome everybody to another one of James's videos. Today we are going to be dealing with financial maths and more specifically annuities. Now grade 12s, this is something new to you guys. Annuities are actually what we use in everyday life. It is the most common thing in financial maths it's more of a, you can take this into your everyday usage of life going forward. So let me just first start off by explaining what an annuity actually is. An annuity is when you make equal payments at equal intervals of time. And you get two types of annuities. You get a future value annuity and a present value annuity. Now, before I explain to you exactly what a future value annuity is, how we recognize what scenario is what type of annuity is when we say to ourselves, okay, well, if I'm making equal payments at equal intervals, are those equal payments that I'm paying making my amount to be a bigger value in the future, or is it currently making a present value decrease over time to make it a much smaller or zero value in the future? So let's look at a scenario. If I'm investing money, meaning I'm putting money away, I'm putting a little bit of amount of money every single month away so that in the future, I'm going to be having a big amount of value. That would be considered to be a future value annuity. So investments, savings, retirement annuities, every scenario where you're putting little bit amounts of money away at equal intervals, equal amounts at equal intervals, will be considered to be a future value annuity if you are wanting in the future a massive amount of money. Now, a present value annuity works the other way around. Presently, we have a big amount of money and we are putting little equal amounts away at equal intervals so that eventually that present amount of money becomes nothing. And that would be an example of loans, mortgage bonds, house loans and mortgage bonds are the same. Car financing, so means when you go to the dealership and you get a car, they finance the car for you, meaning they're loaning you majority of the money and you're paying it off over time. So that would be considered as a present value annuity scenario because you are paying small amounts of money into a loan so that it decreases the amount that you owe someone and the loan amount. Okay, so does everyone understand the concept of an annuity? It's very important to know that because when we are reading a question, we need to be able to say, oh, this person's making equal payments made at equal intervals, therefore I'm dealing with an annuity. Okay, so from there, we obviously have our formulas, which I didn't write down. So let me move my stuff down a bit and let's write down our future value and present value annuity formulas. So our future value annuity formula is, let's make it white here. We're going to say future value equals x, open bracket, 1 plus I to the n minus 1 all over I. Okay, and then our present value annuity formula is very similar, just with a difference of shifting certain things. So x, 1 minus 1 plus I to the minus n all over I. Okay, so something that we need to just realize is that the x in both of these, the x stands for equal installments. Okay, or payments, however you want to look at it. Installments and payments are the same thing. Okay, your I is obviously your interest. Your N is the amount of time that you are taking the annuity out or paying the annuity back. And your future value, present value is self-explanatory as well. Okay, so these formulas are important. We need to know them. I think we do get given to them in our exam, but my moral or my way of looking at things, if you need a formula sheet in your exam, you haven't practiced enough, okay? So try and through practice, learn this formula. I'm going to start off with a future annuity example. Ahmed is now 30 years old. He decides to make financial plans to retire at the age of 55. He will need a capital amount of 2 million rand. Determine how much he must deposit every month into an investment account at 9% per annum compounded monthly. So this is an investment, but also more specifically, it's a retirement annuity, right? Because he's putting money away for his retirement. So immediately I know, okay, cool, this is a future value annuity formula example, because he's putting small amounts away so that in the future he has a big amount. So I first start off by writing my formula. Okay, so in the future, how much am I wanting? I'm wanting 2 million. And I'm wanting to figure out how much I need to put away every month so that I have 2 million in the future. And I've got other information here. I've got a 9% compounded monthly to the power of, okay, well, now we have to work out our N, right? Our N is going to be 55 years minus 30 years. So how many? Because he's 30 now and he wants to retire at 55, which means he has 25 years to be able to put money away for his retirement. So that's going to be 25 times 12. Do you agree? Because obviously whenever we're working with however our interest is being applied, our N needs to match that. So because our interest is being compounded monthly, our N also needs to be in months. Okay. And then that is all over I, which is 9% over 12. So what I want to maybe bring up here is that everything must be in sync. So X is monthly payments. This is a monthly interest rate. And this is months. So everything needs to match. So if you're making monthly payments, your interest needs to be monthly as well as your time. Okay. Fantastic. So now we can go ahead and make X the subject of the formula. So just a little bit of algebra here, guys. So we're going to bring the 9% over 12 up to the 2 million, and we're then going to divide everything by the big set of brackets at the top there, the 1 plus 9% over 12 to the 25 times 12 minus 1 equals X. Okay, therefore X is going to equal, and let's put that into our calculator. Okay, and once we've put that into our calculator, we have 1,783 Rand and 93 cents. Okay, fantastic. And that is how we do a future value annuity question. Great. Okay, now let's move on to the future value annuity examples. I've put 2 here just so that we can see how it works both ways. So let's put that there. Let's zoom in over here. So here we've got Miss van Skalkwyk needs to borrow money to repay a debt. How much can she borrow if she undertakes to repay the loan by making 20 equal monthly payments of 800 Rand each at 11.6% per annum compounded monthly? The first payment is made 1 month after the loan was granted. Okay, so that last little sentence there just means that in a normal scenario, you always make a payment after 1 payment period. Your first payment is made after 1 payment period after you've taken out your loan. So that is a normal scenario, meaning our N will remain untouched. So what we're going to be doing here, we can see we're paying money back. So it is a loan. So it's going to be a present value annuity. So we write the formula out. And we're wanting to know how much she can actually borrow. So we're wanting to work out the present value. And we're going to be paying 800 Rand every month. 1 minus 1 plus, we've got 11.6% over 12 to the power of minus 20. Now, why is it not minus 20 times 12? Because they already told us that the N value was in terms of months. 20 equal monthly payments, okay? All over 11.6% over 12. So therefore, your PV, your present value, is going to equal, and we put that into our calculator, 14,485 Rand and 1 cent. Okay, so that is how much that she can borrow if she pays 800 Rand every single month for 20 months. Fantastic. Okay, let's move on to the next question. The next question is another present value. How do I know? Bianca obtains a loan, obviously already seeing this tells me it's present value of 165,000 at 17.5% per annum compounded monthly from a bank to purchase a car. Determine the monthly payments if the loan commences 1 month after it has been granted and is paid off 5 years later. Okay, again, present value annuity. So I'm writing my present value annuity formula. A lot of people make mistakes and they forget that minus n, guys. So don't forget that it's a minus n in the present value annuity. Okay, so we've got a present value that we're loaning of 165,000 Rand. We're wanting to know how much we need to pay monthly in order to pay back this loan. So x is unknown. 1 minus 1 plus the 17.5% over 12 to the power of 5 years. So minus 5 times 12. Okay, they've given it to me in years, hence is why I need to times it by 12 to make it months. All over 17.5% over 12. Okay, now I'm going to do some algebra, and I'm going to make x the subject of the formula. So I'm going to leave the 165,000 Rand this side. I'm going to bring the 17.5% over 12 up and times it. And then I'm going to take the big bracket that's timesing by the x and bring it below the fraction. 17.5% over 12 to the minus 5 times 12. That is going to equal my x. Therefore, x is going to equal. And I'm going to put that in my calculator. X is going to equal 4,145 Rand and 17 cents. That is how much you need to pay monthly back for the next 5 years in order to pay back this loan of 165,000 Rand. Great. Awesome, guys. So that is your types of annuities that you're going to be dealing with. And everything to follow, the other types of questions will all be based on annuities. So this is the start. This is the foundation. I hope you enjoyed the video. Please, if you want to see more, click the subscribe button and look out for more videos coming up. And also, if you are wanting all these notes, we are selling the James book, which will be available. And if you are interested in purchasing one, please comment or message us and get in contact with us. We'd be happy to supply you with one. Great. Have a good day and look forward to seeing you again.